This is how Earth looks like from above the Indian subcontinent. And this image is very special, at least for me, because I have captured this directly from a satellite in orbit using this antenna. And guess what? Even that has been designed by me. See, traditionally the images of Earth that we see on Google Earth are from Google's database. And Google takes the liberty of blurring things which government bodies do not want us to see. But in this case, no blurs. You can see everything that the satellite sees, at least technically. Now I know a lot of you might be questioning,
Was all this legal?
of course it is. Okay, as far as I know. So I started with designing an antenna. In my case, I wanted to use the same antenna for multiple frequencies, because obviously I don't want to fill up my terrace with multiple sized V-shaped antennas, because I live in a building and I simply cannot plug in an antenna over there permanently. Well, my neighbors won't like it. And there is a very good solution to this by which I can make sure that I can receive satellite frequencies on different bands. See, the frequency of a signal is inversely proportional to its wavelength, and the size of the V dipole is proportional to the wavelength of the frequency. So by using a telescopic antenna, I can actually change the length of the two dipoles and effectively change the frequency for which it has been tuned. Now I don't exactly have a VNA device with me, but I'm sure that this will work very effectively. Source?
Trust me, bro.
Now, also being a 3D printing perfectionist, I designed this enclosure which keeps everything clean. The best part? This antenna can be made for less than $10 and all parts are in the description. I have also made a video guide to show you how to make it. Now we need a receiver. See, the NOAA satellite transmits at 137 MHz, and to receive at this frequency we need a SDR, a software defined radio. SDRs, however, are very expensive and definitely not in my budget at the moment. But here comes this thing, the DVB tuner based RTL SDR. It's awesome. You can listen to FM on your computer using this. You can also receive data from geostationary satellites, which means you can watch TV on your computer. Come on, at least that's cool. Maybe not exactly these days. Speaking of SDR, another interesting project that I'm working on is receiving submarine signals from various ground stations. I did find some luck in receiving signals from a substation in Australia. This particular submarine transmission station is featured a lot of times in, spooky alien documentaries. Most of the time it gets speculation because of its structure supposedly. But yeah, that's needed because, we are operating in VLF frequencies and the antenna length increases significantly with reduction in frequency. So make sure to subscribe to the channel and hit the bell icon for more such interesting projects. So I just found that the satellite is going to pass from my area in just about 30 minutes. And yes, let's try to quickly assemble this antenna. Let's try to get this pass and see if this actually works. So I quickly assembled the antenna and there's not much time to test it now. Let's just attach it to the tripod and just head out. Alright, we are on my terrace and just listen to this. This is on 137.100 MHz, and the best part is my laptop is also receiving the signal from the antenna. Speaking of laptop, the temperature is actually very hot. I'm worried if my laptop is actually getting cooked from this, and I don't want that. The problem is that I don't have a spare and it's my work device. I wish people could support the channel somehow. So because it was getting really hot there and I was worried about the laptop, I stopped the reception and I went home.
6 hours later.
We are on terrace. I'll quickly set up everything and start recording.
A few moments later.
So finally I have set up everything and started recording. I was late by about 5 minutes. So the initial 5 minutes of the data won't be received, but that's fine.
Few minutes later.
And here we are, the entire recording was complete. Let's just click on auto process and ta-da! I'm not sure why it is dark. I think maybe there's some filter issue. Let me change some filters. Let's try on this IR filter. Same thing. Let me quickly check what's happened. So I listened to that raw audio file and turns out the NOAA image decoding software was actually recording to my laptop's microphone and not the SDR at all, because there's some setup for virtual cable, and I'm sure I did it previously because that's how I recorded it in morning. but this time it was default set to my laptop's microphone, which is strange, and that's the reason we got a black image over here. That's actually really sad, so we'll try to listen to it tomorrow.
One day later.
So now I am recording directly from the terrace. This time I made sure to arrive 10 minutes early, and I am recording from the topmost part of my terrace unlike previously. So there will be no obstruction from any side because of any walls, etc. And we should be able to receive the entire transmission for the entire satellite pass.
A few inches later.
Alright, the entire transmission was complete, and here are the final results. I really like these images, though there are a lot of problems with these. First of which is that these are from NOAA 15, which is a much older satellite. The images from NOAA 18 and 19 are of a better quality is what I've read from many subreddits, and the next task is to actually record NOAA 18 or NOAA 19, and I plan to do that in the next video using my Raspberry Pi. So instead of using my laptop, it will be much easier to control a Raspberry Pi on my terrace. And my plan for upcoming transmissions is to upload them directly on my YouTube community itself, so I won't need to make video for each and every transmission. For getting updates about those images, make sure to subscribe to the channel and hit the bell icon.